All right, let's begin here. So last week, what did we learn here? What did we learn? We learned several different functions. Let's go back to see what we learned from last week. Actually, last week we learned, firstly, let me say it again. If you have any questions, please unmute yourself and question anytime. So make sure we don't bring a question to the next class. And let's review last week. Last week we focused on function. We talked about the function properties. That's why I say each of the input x, only one output x. We talked about linear line. Oh, Ben was doing, yeah. And also talk about the quadratic parabola curves, like only one input and one output. And then we talked about the domain. Domain is the combination of x. And we also talked about the range is all the combination of outputs. And we also talked about function notation and evaluation. The notation actually is formatted like this, like f, and including the input. So this is called function notation. So inside the bracket, this parenthesis is the input, and the expression here in the backside is the formula. So you just only need to replace the x with the input. So you can get the evaluations, right? And we have many examples. And we also use your homework part. Let's quickly review the homework part if you're not familiar with this one. So we talked about this one as well, right? In the last classes already, saying when your input is A, actually replace the A with the X, replace X with the A. So you can get 4A plus 1 like this, right? So if you replace the X with 3C, so 4 times 3C is 12C, right? 12C plus 1. So this is the result. So here, the same, replace X with negative X. So you got negative X plus 1, right? Only change here. So if you replace the X with the A plus 3, so it's 12A plus 12, but plus 1. So you got a 4A plus 3. Yep, got it. So A plus H. So you got a 4A plus 4H and plus 1. So not like this, right? Not like this. Not like neither. Right? Okay. So homework part, this one we talked already. So we also leave you as your homework as well. Same here. So you replace the X with the 3B. We replace the X, replace this X with 3A, right? And the same here, replace the X with the X plus H. And it became the left part. The right part is replace the X with X, so it's nothing changed. Here, replace the X with H and combine it here. We prove that one, this not make sense, right? Because the left part not equal right part. That's the question here. Does this one equal together? Actually, no, right? The answer, we got it. So if you're not, go back to see the video part. And also graphing this called exponent reverse, right? Reverse rational function. Rational function actually is, look, we're graphing this part like this. And you can find the domain of X. X cannot be equal 0, right? So it's negative infinity to 0 and 0 to positive infinity, but not equal 0. You can see here, this part, x cannot be equal 0. Right? What about y? What about the domain? Domain is also from negative infinity to 0. It's close to 0, but never equal 0. And also from 0 to positive infinity, but not equal 0. So actually, the result would be for the range is negative infinity to the 0. So this one use the parenthesis, not this one, right? And from 0 to positive infinity. So that's the range. So go back to see the video if you still not well understanding this part as well. And we also talked about the exponent function, and also radical function, right? Radical function. This is actually partially of the exponent part. When they go into the whole numbers, this is like exponent. But go fractions, when we go to the radical part. With radical part, we only focus on the very basic part, something like half. It means square root is radical part function. And we also extended a little bit to the rational function. That's the rational in the denominator and denominator and numerator. Both are polynomials. And its listation, how they graphing. So this one is a little bit challenging. You need to go to the high school part where we get this part, learn this. Here we just very roughly to introduce this part, how to get it, especially when there was not possibly, when their denominator cannot equal 0, right? So x cannot equal. Right here, it's just like based on factor process. You can well know that x, so this part can be, factor into like x minus 3, x plus 2, right? So it cannot equal 0. So at least you find out x cannot equal positive 3 and x cannot equal negative 2, right? So you find out the domain. Domain is negative infinity to negative 2, and negative 2 to 3, and 3 to positive infinity, right? So you can see also here. Actually, they are very close to 2, but not equals to 0. So it just means that when like give you the domain, the range part would be a little bit challenging for you guys to get the answer. So this one we don't require here. But just gives you a basic idea. After you draft it out, you can find out what they possibly equals or close to. So today we just move a little bit forward about this part. I know we learned this before actually. We talked about in the these rational equations, how get the solutions. So we move on these topics. Okay, we move on these questions. All right, let's move a little bit right here. All right, let's see this part. So today we talk about rational equations. This part we actually teach during the Algebra 1. So we review this part. So make sure we can actually learn a little bit deeper about this part. Earlier we say rational equations. Most of the time we close to proportional. Something like say x minus 2, x minus 3 equal x minus 4 divided x minus 6. And this is called proportional, right? Left part, right part. they both is rational expression. So that would be easy. So use the cross multiply methods, right? You can use the cross multiply methods to get the solutions. Cross methods so means this actually is somewhat is called proportion, right? Proportion is the extended part. Proportion. So you can use the cross multiply methods to get the solutions, right? So you can get it. So like this one say you can get x minus 2 get times x minus 6 equal x minus 3 times x minus 4. The question here is you cannot, x cannot equal 3 or 6, right? Cannot equal 3 or 6. All right. So what do you got? So here you can use the earlier text method, say x squared minus this minus 8x plus 12, right? Equals x squared minus 7x plus 12. So you got what? You can combine like terms. So negative x equals 0. So it means x equals 0. So they didn't conflict here, right? So x equals 0 can make this rational expression make sense. You get this kinds of solution. So today we got a little bit further step. So this kinds of rational expression right now is not rational expression. They have extra parts. Like this one, they already have 2 parts. So actually the result is the same. We just need to transfer this part into rational expression as well, right? So they have multi-parts. This rational expression right now have some other combinations. This is rational expression. So we need to transfer these kinds of rational expression into rational expression, only the denominator and denominator. How we do that? They are pretty the same as what we do for when we do the called rational expression, make a simplified process. All right. So what we can do? Firstly, step. Let me pull this up quickly. Actually, I already write down here. The first step is identify the least common denominator. All right. So find at least least common denominator. How we are like this one. Like let's see this example first. So what's the denominator for this part? They have x minus 1. For this part, we can say it's 1, right? And for this part is 2. So what's the least common denominator? Is 2x, x plus 1, right? So we can, so at least in these cases, x cannot equal negative 1, right? Here, at least. All the denominator part cannot be equal 0. So it means x cannot equal 0, x cannot equal negative 1. This situation. So if x cannot equal 0, x cannot equal negative 1. So this least common denominator, so will not equal 0. So we can time both sides with this common denominator. All right. So what needs to be changed into? Let's say with this part time this common denominator. So left part also time here 2x, x plus 1. Okay. All right. So let's do this one. So the rest part is will be very the same as what we earlier doing. We firstly need to distribute inside. This one distribute inside here, x plus 1 will be gone, right? So here it became 4x squared. And what about right part? Right part here is this time 2x, x plus 1, right? Minus 5. So here, when you time inside this part, will be the common denominator is be crossed out, right? So here it became 5x plus 1. So right now we transfer into polynomial, right? Is it correct? Anyone have question here to this part? Anyone have question to this part? Hello, can you please unmute yourself if you have question? Okay, all right. So here we can do the further simplify, right? So here, okay, 4x squared plus 4x, right? Minus 5x minus 5. All right, so here was combined, and here became moved to the left, became x equal -5, right? So we got it, got the solutions. So this one, find the solutions of the rational equation. So let's, if you have time, you'd better to double check it, all right? So 2 times, let's see the left part. Left part is 2 times -5 is -10, right? -5 plus 1, -4. So here is 5/2. What about right part? Right part is 2 minus 5, 2 times -5 equal what? 2 minus half. Actually 2 plus half, right? Because of here negative. So it's 2/5. So they are match up. They are match up. Yeah, makes sense. Right? So this result is correct. Is it good? Anyone understand this part?
Yes.
Thanks. Thank you. I need a question. Kong Wei?
Yeah.
Yeah. Okay. Michelle, what about you?
Yeah.
All right. Ryan, what about you, Ryan?
It makes sense.
All right. Okay, good. All right, let's see next one. Let's see this one. All right. You guys maybe heard some noise in my backside because of my kids Brian was in the backside watching iPad. Hopefully there's not too much noise. All right, so see this one. All right, so what's the first step? We still need to find the least common denominator. You can see here. Firstly is identify least common denominator and then multiply both sides with the least common denominator. Simplify the denominator should be gone, and then solve the result equation. Check the answer, all right? So the step is pretty clear, right? All right, so see this part. Actually, before we go this part, we need to identify here is the denominator, and denominator. All right, looks like this denominator can be further factored. So we use the methods we do ever learn. So this one actually can be factored into a minus 6, a minus 2 times a minus 2, right? So the least common denominator will be this one. It's not this one. I think I teach very early. Someone said least common denominator will be like this. Make it very complicated, all right? This is not least common denominator actually, because of this part, it can be, just like we say, it can be factored. So least common denominator actually is this part. All right. Okay. So both sides times the least common denominator, actually we can say. Right. So here we generate this part and least common denominator time both time here. All right. Let me get the unnecessary stuff out. All right. So this is so with a so after that, after this, we use this one distribute inside, right? Distribute inside this part, distribute inside. So here you can got a times a minus 6, right? First step is because a minus 2 is gone, disappeared. Second part after you can use inside, you got a minus 2. What about right part? Right part, this one time here is all gone, right? Equal 4. So you can see it's became much more simplified version. So we combine all the like terms. Minus 6, right? So got 0, right? So you can continue factor. We can know here is negative 6, positive 1. It's a positive 1. So you can got a equals 6 or negative 1. Here a cannot equal 2, right? A cannot equal 2. A cannot equal 6. So here say a equals 6 or a equal negative 1. After this combination, we need to get rid of this one, right? A equals 6. Let's say a cannot equal 6. So a have only one answer is a equal negative 1. Right? Everyone got it here? Angela?
Yeah.
Okay. Enoch?
What?
Did you got it? Did you have questions?
No.
All right. So that's the easy part, right? That's the easy part. Okay. All right. Let's move on next. So Lizzie, we just go back to review rational equation. We make it a little deeper. We find the LCD and multiply both sides and then simplify it down and get the solutions. So what about inequality? Rational inequality. They are actually basically the same, right? Only change the equal into inequality. But keep in mind first. Keep in mind first. Keep in mind first. Just like any these kinds of inequality, rational equality, rational equations, you need to figure out when the top and bottom both sides are positive, when they divide, they're still positive. When both sides is negative, both top and bottom is negative, and you got a result is positive, right? If the denominator and numerator is opposite, something, one is positive number, one is negative number, one is a positive number, one is negative number, the result would be negative, right? The result will be negative. So if you want to find out, let's the two denominator and numerator, they are both positive, they will be good result is positive. If both negative, result is still positive. If the numerator and denominator are opposite, I mean, they are one positive, one negative, the result will be negative, all right? So that's one would be, just keep remind here. You guys definitely know this better than me. Okay. All right, so let's move it. Let me move this one to other spot. So when we do this situation, how we do this here? So how we do this one? Do the rational inequality. So they both have this situation as well. So how we do that? Okay, let's give some example. Let's be easy for understanding here. So definitely you need to, what do we need to do? We need to move all part into one side, right? You can say -2 less than 0, all right? So let one side became 0. All right, let one side become 0 first. So you make it like this. So x -2. What about here? Here is -2x plus 3, right? Less than 0. So what do you keep this in mind? So similarly, like say 1 plus 3, 2, like this one. So you need to make this one 3 and 3, right? So after that, you can say 3 plus 2 equal 5. First, make the denominator the same, and then you do the calculation only the numerator part, numerator part, right? The same here, okay? All right, so what's next? What's next? So we simplify it and make it more well to looking, right? So what about the denominator part and numerator part simplified? So here became, I'm sorry, I wiped something off here actually. So here became -x minus 7, right? X plus 3 less than 0. All right, we can make it even simplify. Both sides times -1. So here times -1, times -1. So when they time negative numbers, we need to change alligator mouse, right? All right, so here became x plus 7 because that one was changed, and plus, I'm sorry, x plus 3 greater than 0. Just like we're saying here, when, so this number and this number should be both positive or both negative, right? Both positive. So needed to x plus 7, both greater than 0 and plus greater than 0, or both negative. Both negative. So here you can get what? X greater than -3, x greater than -3, -7, -3, or x less than -3 or less than -3. So here means what? So after combine these two, which one is bigger? -3 is bigger, right? So here is -3, or which one is big? X less, which one is smaller? Actually, -7, right? So the result is this part. Actually, result is this part. This part. It makes sense? So if we write into notation, interval notation method, it will be written into like this. Or means this one. Or, we say or, and -7 and positive infinity. All right. So that's it. That's it. So what's the challenge process here? Actually, you guys maybe see the challenge process is this part. Change it to this part. Make the denominator the same. And the rest is this part judgment. How you judge it to get here, right? How you judge to get here? You need both top and bottom should be both positive or both negative. We judge from these kinds of principle. So if they are both positive numbers, when they divide, it will become positive. So positive number definitely will be greater than 0, right? If they are both negative, this result will be still positive. Positive will be greater than 0. That's it come from. If this one say less than 0, so we need to one of them greater than 0, the other one less than 0. But we will use this example to talk about it. Okay, so let's see next example. Let me go back, save a picture here first. Okay, so see this example. All right, this example is, say, so this one actually we can transform a little bit. Less than or equal 0. Less than or equal 0. So we can transform into this one, both sides divided 4. Both sides divided 4. So this one will be transformed into less than or equal 0, right? So you don't need this 4 now. So it will be transformed into like this, right? So when this number less than or equal 0, what do we can change here? What do we can change here? We can see this one. So what do we can transform into? All right, so x at least cannot equal 4. That's the basic part. So we want to be transformed into. So it means these two numbers are opposite to each other. So if we say this one greater or equal 0, all right, so the second part should be what? Should be less than 0, right? Or this part less than or equal 0, and this part should be greater than 0, right? Do you see this one? Actually, because of the denominator cannot be 0, that's why here there's no 0 here. All right, so the rest would be more easier. So since we transform rational expression to our normal inequality, right? Rational inequality to normal inequality. Just simplify it down. So it will be not so challenging, right? Not so challenging. So we'll be transformed into 1. So x greater equal -1, and this one is x less than 4. So this number should be what? Should be x less than. So did you see it makes sense? I mean, oh, sorry. It's a number less than -1, but at the same time, less than 4, right? So yeah, it makes sense. It's less than 4 and greater and equal than -1. Of course, makes sense, right? Like 0. You put 0 in here. Right? What about right part? Right part is x less than -1, but at the same time, x greater than 4. So this one not make sense, right? Because when a number less than -1, it's impossibly greater than 4. So here is nothing. It's nothing. So only answer is this one right now. Okay. All right, take a 5 minutes break and come back. Go get some water, take a bathroom and come back. All right, and talk to you soon.